Now let us look at examples on washer method. So I only used exactly the same given except that we revolve the generator with respect to a different axis. So let us find the volume of the solid generated by revolving about the axis of revolution. The axis of revolution is x-axis. The generator is bounded by y equal to square root of x, y equal to 2, and y-axis. So you can see that on the right hand side. But this time we will be revolving it with respect to the x-axis. So as you can see here in this solid of revolution, if we will cut a slice somewhere here, we will get a washer. A washer because there is a hole in the middle of the slice. So to solve this, we use the washer method. Still using the concept of the slicing method. So the area of the cross section. So now the volume of the solid of revolution is given by pi times the integral of. By the way, we will be integrating with respect to x since the revolution is with respect to x. The radius of the outer circle square, and that is given by y equal to 2. And here, the lower portion is defined by y equal to square root of x. So we have 2 square minus square root of x square. So let me move the dx here. Then we will be evaluating from 0 to 4. Okay. Simplifying the integrand, we get 4 minus x dx. Integrating, we have 4x minus x squared over 2, evaluate from 0 to 4. Now substitution, we have 16 minus 8 minus 0. So the answer is 8 pi cubic units. Let's look at another example on washer method. Let us find the volume of the solid under the curve y equal to x squared plus 1. So meaning our generator is bounded by y equal to x squared minus 1. It's revolved about the y-axis. So the axis of revolution is the y-axis from 1 to 4. So here is 1 until 4 only. Now revolving this generator with respect to the y-axis, we get this solid of revolution. Looking at a slice here in the solid, we get a washer. It's a washer because there's a hole in the middle of the slice. So to find this, we still use the concept of the slicing method. The volume is given by pi integral of the radius of the bigger circle of a cross section. So meaning it's this. Let me use another color. This side here, and it's given by x equal to 4. So I have here 4 square minus the radius of the smaller circle when we revolve it with respect to the y-axis. And this is given by, let's solve that. We are given y equal to x squared minus 1. x squared is equal to y plus 1. So x is square root of y plus 1. So let's replace that here. Square root of y plus 1 square. Integrate with respect to y. And as you can see, our y ranges from 0 until 15. So this is 0 to 15. Okay. You can actually solve for y, no? When x is 0, y is, yeah. No, it's not 0, 1. When x is 1, we have y equal to 0. And when x is 4, y is 15. That is why the limits of integration is from 0 to 15. Now let's proceed with the integration. Pi integral of 16 minus y minus 1 dy. Therefore, we can simplify this further into pi integral of 15 minus y dy. The antiderivative is 15y minus y squared over 2. Evaluate from 0 to 15. When y is 15, we have 15 times 15 is 225 minus 225 over 2 minus 0. When y is 0, we have 0. So what's our final answer? So we will have here pi times 450 over 2 minus 225 over 2. So that's 225 over 2 pi cubic units. This is the final answer.